Hello everyone, in this video we will learn all about solving oblique triangles. Oblique triangles are triangles with no right angle. Now, there are two possibilities. Is the triangle right angled? Now, you can answer yes or no. If you will answer yes, you can make use of the Pythagorean theorem or you can make use of the SOHCAHTOA. Now, if you will answer no, then you can make use of the law of sines and the law of cosines. So let's start with the law of sines. Now, let's derive the formula for the law of sines. Now, given this triangle ABC with sides as small letter A, small b, and small letter C. So first, draw an altitude of the triangle from vertex C and let's label this as H. Now, next, using trigonometric ratios, form an equation that will solve for sine A or sine B. So let's start for sine B. So sine is opposite over hypotenuse. So in this case, the opposite is H and the hypotenuse is A. So with this, you cross multiply. So H is equal to A sine B. Okay, another. Now for sine A, the opposite is H and the hypotenuse here is B. So let's substitute H with A sine B. So with that, sine A will become A sine B over B. So cross multiply further, sine A over A is equal to sine B over B. So take note, capital letters are for angles and small letters are for sides. So basically, this is the formula for the law of sines. Okay, so again, the law of sines. So that would be sine A over A is equal to sine B over B is equal to sine C over C. If we are talking about angles, if we're talking about sides, so that would be A over sine A is equal to B over sine B and C is over sine C. Okay, now the law of sines can be used if the given are ASA or AAS, or it could be side-side angle. So let's have an example. Given this triangle, the measure of angle A is 60 degrees, the measure of angle B is 70 degrees, and side A is 8. So find the rest of the missing properties of the triangle. So sketching this, we will get this. So again, angle A is 60, B is 70, and A is 8. So to start, let's solve for angle C. So take note, the measure of all three angles in a triangle, that's 180 degrees. So 180 degrees minus 70 degrees minus 60 degrees. So we will end up with 50 degrees. So with that, angle C is 50 degrees. Okay, next. So let's solve for B, side B. So with that, side B over sine B is equal to A over sine A. So why A over sine A? Because side A is given and angle A is also given. So at this point, let's substitute. B is 70 degrees, A is 8, and angle A is 60 degrees. So cross multiply this, we will get this. So using your calculators, so 8 divided by sine 60 times sine 70 degrees, the result here is approximately 8.68. So with that, side B is 8.68. Okay, next, to solve for side C, that would be C over sine C is equal to A over sine A. So substituting, we will get this. So cross multiply. So using your calculators, 8 over sine 60 times sine 50, the result here is 7.08. So take note of this. Now, looking at the given, the biggest angle is angle 70 degrees or angle B. And the longest side is side B. While the smallest angle is angle C and the shortest side is side C. So take note of this. The bigger the angle of a triangle, the longer will be its opposite side. Or, the smaller the angle of a triangle, the shorter will be its opposite side. So that is triangle inequality theorem. So take note of this. Okay, another given. So, this one, you're given here angle A is 42 degrees, angle C is 70 degrees. So, to find the missing angle, so that would be 180 minus 42 minus 70. So that would become 68 degrees. So at this point, we can solve for C. So C over sine C is equal to A over sine A. So A is 6, sine 42. So cross multiply, this would become 6 sine 70 over sine 42 degrees. So we will end up with 8.43. Okay, another. To solve for side B, so that would become B over sine 68 is equal to 6 over sine 42. So cross multiply, and making use of your calculators, the value for B here is 8.31. So take note of this. Okay, another. Now this one is angle, side, and angle. So the same thing. This is 60, this is 40. So the missing angle here is 80 degrees. So with this, we can solve for either A or B. So let's start with A. So A over sine 60 degrees is equal to 7 over sine 80 degrees. So cross multiply. We will get this using our calculators. The value for A here is 6.16. Okay, another. For side B, that would be B over sine 40 is equal to 7 over sine 80. So cross multiply, we will get this. Use your calculators. The value for B here is 4.57. So take note of the three angles. The biggest angle is angle C. And take note, the longest side is also side C, which is 7. Of these three angles, the smallest is 40 degrees, which is angle B. And the shortest side is also side B, which is 4.57. Okay, another given. A triangle with angle A as 85 degrees, A as 12, and B as 7. So find the rest of the missing properties. So sketching this one, we will get this. So we will solve first for angle B. So with that, we'll get this ratio as sine B over B is equal to sine A over A. So substituting, sine B, it's a known, so B7. A is 85 degrees and side A is 12. So cross multiply, we will get this using your calculators. Sine 85 degrees over 12 times 7. So that would become B is equal to arc sine 0.5811. So shift signs, you'll get this degrees, minutes, and seconds, or that's approximately 35.53 degrees. So that's the value for angle B. So if we have B, we can now solve for angle C, in which that's 180 degrees minus 85 degrees and 35.53 degrees. So the value for C here is approximately 59.47 degrees. So with this, the missing is side C. So for side C, we can have C over sine C is equal to A over sine A. So substituting, we'll get this. Cross multiply. So that would be 12 over sine 85 times sine 59.47 degrees. So side C here is around 10.38. So take note of this one. Okay, another. Now this one, we have here 30 degrees. The opposite side is 9. We have 15 centimeters. The opposite angle is theta. And we have here side x. So solve for theta and x. So to do this, we will solve for angle theta first. So that would be sine theta over 15 is equal to sine 30 degrees over 9. So cross multiplying, we'll get this. So that's 15 sine 30 over 9. Using our calculators, so that would be 0.833 arc sine. So that would be 56 degrees, 26 minutes, and 33.68 seconds. So if that's the value for theta, so to solve for the third angle here, so that would be 180 degrees minus the value for theta and minus 30, we'll get approximately 93 degrees, 33 minutes, and 26.32 seconds. So to solve for x, that would be x over sine 93 degrees, 33 minutes, and 26.32 seconds equals sine 9 over sine 30 degrees. So cross multiplying, you'll get this. Using your calculators, x is 17.97 centimeters. So take note of this. Again, of the three angles, 93 degrees is the biggest angle, and of the three sides, x is also the longest side. The Leaning Tower of Pisa in Italy leans at an angle of about 84.7 degrees. The figure shows that 171 feet away from the base of the tower, the angle of elevation to the top is 50 degrees. Find the distance from the base to the top of the tower. Now, given this, we have to solve for the missing angle first, so which is angle C. So with that, angle C is 180 degrees minus 84.7 minus 50 degrees. So with this, the value for angle C is 45.3 degrees. Okay, next, we have to solve for the height, or B. So with that, we'll have this. B over sine 50 degrees is equal to 171 over sine 45.3 degrees. So cross multiplying, we'll have this 171 sine 50 divided by sine 45.3 degrees. Now, making use of your calculators, the value for B here is 184.29 feet. So with this, the distance from the base to the top of the tower is 184.29 feet. Law of cosines. Now, the law of cosines states that the square of the length of one side is equal to the sum of the squares of the other two sides minus the product of twice of the two sides and the cosine of the angle between them. So basically, this is the formula for the law of cosines. Now, the law of cosines can be used if the given triangle has side, angle, and side given, or it could be angle, side, angle given. Now, let's have the proof how this formula is derived. Now, given this triangle here, we have angle C, we have side C, and the other two sides as A and B. Now, let's draw an altitude, and let's have this as h. Now, let's have the separated parts here as x and the other one here as y. Now, take note with this y, we can rewrite this as b minus x. And squaring both sides, we can have y squared is equal to b minus x squared. Okay, another. Now, referring to this right triangle here, we can have the Pythagorean theorem as x squared plus h squared is equal to a squared. Or we can rewrite this as h squared is equal to a squared minus x squared. Okay, another. Now, solving for cosine C. Now, cosine is adjacent over hypotenuse. Now, referring to this, the adjacent side is x and the hypotenuse is a. So, cross multiplying this, so a cosine C is basically x. Now, referring to this right triangle here, we can form, using the Pythagorean theorem, this equation. C squared is equal to h squared plus y squared. Now, take note, h squared, we can replace that with a squared minus x squared. The y squared, we will replace that with b minus x quantity squared. Now, expanding this one, this would become b squared minus 2bx, and the square of the second is x squared. Again, we can cancel negative x squared and we can cancel x squared. So with that, we will have a squared plus b squared minus 2bx. Now this x, we can replace this as a cosine c. So with that, we have this formula, c squared is equal to a squared plus b squared minus 2ba cosine c. So that's how the formula for the law of cosine is derived. Okay, given this triangle here, we have angle A that measures 40 degrees, side B is 7, side C is 8. So find the rest of the missing properties of the triangle. So with this, we will solve for A. So making use of the law of cosine formula, we will have this. So let's substitute. Our B is 7, our C is 8, and cosine A is 40 degrees. Now, simplifying this 49, 64, 112 cosine 40 degrees. Now, making use of your calculators, that's 49 plus 64 minus 112 cosine 40, we will get this. So, getting the square root to both sides, so the value for A is 5.22. So, next, with this, we will solve for angle B. So, we will use the law of sine. So, sine B over B is equal to sine A over A. So, substitute. Our B is 7, our A is 40 degrees, and our A is 5.22. So, cross multiply, we will get this. So, sine 40 degrees over 5.22 times 7. So, we will have arc sine 0.8619. So, angle B is 59.54 degrees, or the exact value of that in minutes will be 59 degrees, 32 minutes, and 20.93 seconds. So, next, to find for angle C, so take note the total of all angles is 180 degrees. So, that's 180 degrees minus 40 minus 59.54 degrees. So, simplifying, angle C is 80.46 degrees. Or making use of the exact value, that's 80 degrees, 27 minutes, and 39.07 seconds. Okay, let's have another example. Okay, let's have this. All the given here are sides of a triangle. So this is SSS. So our A is 6, our B is 7, our C is 5. So find the measure of the angles. So again, making use of the law of cosine, we will have this. So we can derive for cosine E, or we will simply substitute this one until the end. So A squared minus B squared minus C squared. So transfer this, we'll have negative 2BC cosine A. So divide the entire equation by negative 2BC. So we will end up with cosine A is equal to B squared plus C squared minus A squared over 2BC. So at this point, we will substitute. Our B is 7, our C is 5, and our A is 6. So, divided by 2 times 7 times 5. So, simplifying this, we will have 38 over 70. So, solving for A, that's arc cosine. So, 0.5429. Making use of your calculator. So, angle A here is 57.12 degrees. Or in exact measurement, that's 57 degrees. 7 minutes and 17.94 seconds. Okay, next, to solve for angle B, so we can make use of the law of sine. So, sine B over B is equal to sine A over A. So, substituting, our B is 7, our angle A is 57.12 degrees, and our A is 6. So, cross multiply, we will get this. Solving for arc sine, so angle B is 78.46 degrees. Okay, now to find for angle C, so that would be 180 degrees minus 57.12 degrees minus 78.46 degrees. So with this, the measure of angle C is 44.42 degrees. Now take note of the three sides. Side C is the smallest or the shortest side, and of the three angles, angle C is also the smallest angle. Okay, another example. So let's have this. So solving for C, so that would be C squared is A squared plus B squared minus 2AB cosine C. So substituting, our A is 12 and our B is 10. So substitute. And our angle C is 67 degrees. So making use of your calculators, we will get this. So C squared is 150.22, getting the square to both sides. So the value for C is 12.26. Okay, another example. Now this one, the three sides are given. So solving for angle B, so that's cosine B is equal to A squared plus C squared minus B squared over 2AC. So substituting, we will have A here as 7, or C as 8, and B here is 5 because it's the opposite of angle B. So over 2 times 7 times 8. So simplifying, this would become 88 over 112. So solving for our cosine, so B here is 38.21 degrees, or in exact, that would be 38 degrees, 12 minutes, and 47.56 seconds. The diagram shows the cross-section of a roof. What is the distance BC across the base of the roof? So with this, we will use the law of cosine in solving for BC. So we will use this formula. So we will substitute. So our B here, let's have this as 13, C is 30, and A is 115 degrees. So making use of your calculators, we will simplify this. 169 plus 900 minus 780 cosine 115 degrees. So we will end up with 1,398.64, getting the square to both sides. So the value for A is 37.4 feet. So with this, across the base of the roof, the distance is 37.4 feet. Solving for the area of a triangle. Now, given this right triangle, to find the area here, that's base times height divided by 2. So the base is 10 and the height is 12. So multiplied and divided by 2. So the area here is 60 square units. Now another. Given this triangle, the base here is 8, but there's no altitude given. Now suppose if the altitude here is 6, so to find the area, it's still base times height divided by 2. So the base is 8 and the height is 6. So divided by 2, so 8 times 6, that's 48, divided by 2, so that's 24 square units. Now another. Given this, we have here an isosceles triangle with the base of 8 and the height is unknown. So to do that, let's draw the altitude. So separating the base, so this would become 4 and 4. So take note, the altitude here, it's forming a right triangle. So with that, we can solve for the height as 5 squared minus 4 squared. So with that, that would become 9. Get the root, so that would become 3. So the height here is 3. So to solve for the area, that's base times height divided by 2. So the base is 8 and the height is 3. So divided by 2. So with this, the area here is 12 square units. Now, another example. Now suppose if I will give this oblique triangle with one side as 4, the other side is 15, and the other side is 13. So with this one, it is hard to find the height. So with this one, we can make use of the Heron's formula. So with the Heron's formula, to solve for the area, that would be the square root of S times S minus A times S minus B times S minus C, where S here is basically A plus B plus C divided by 2. So the S stands for semi-perimeter, and A, B, and C are the sides of the triangle. So making use of the Heron's formula, and with this given, so let's solve first for the semi-perimeter. That's 4 plus 13 plus 15 divided by 2. So we will end up here with 16. So again, 13 plus 15 plus 4, that would be 32. Divided by 2, we will end up with 16. So to solve for the area here, that would be 16 times 16 minus 4 times 16 minus 13 and 16 minus 15. So getting the square root, this would be 16 times 12 times 3 times 1. So with that, the area here is approximately 24 square units. Okay, another example. Okay, this one. A piece of land has dimensions of 12 meters by 10 meters by 8 meters. What is the area of the land? So sketching this, we will have this one, 8, 12, and 10. So solving for the semi-perimeter, that's 12 plus 10 plus 8 divided by 2, so that would become 30, and divided by 2, so that would become 15. So solving for the area, so making use of the Heron's formula, so substitute, that would be 15, 15 minus 12, 15 minus 10, and 15 minus 8. So simplifying, this would be 15 times 3 times 5 times 7. So that would be the square root of 1,775. Get its root. So the area of this land is 39.67 meter square.